Hello everybody, this is a video lesson on section 2.2, quadratic functions. Now what I want you to do is take notes during this video, pause the video sometimes if you want to try some of the examples first, and follow along closely. Now this section is on quadratic functions, and many of you are already very familiar with quadratic functions. They're basically parabolas when you draw them. There are three forms that you should be familiar with. The first one is known as the general form. F of x equals ax squared plus bx plus c. Now, when it's written in this form, the coefficient of the x squared is commonly written as lowercase a. The coefficient in front of the x term is lowercase b, and then this constant term is lowercase c. One of the main things that you learned in Algebra 1 was that the axis of symmetry, which is this line right here, that is a line of symmetry for your parabola, is at an x value of negative b over 2a. So you just take the negative of the b divided by 2 times the a, and you'll get the x coordinate of the vertex. It's also the axis of symmetry because a vertical line is x equals something. So this axis of symmetry has the equation x equals negative b over 2a. Now to get the vertex, you have to plug this x value into your function to get the y value. So the vertex is at negative b over 2a, comma, f of negative b over 2a. Now the y-intercept is c, because that's when you make x equal to 0. These two terms go away, and you have c. If a is positive, then the parabola faces up and has a minimum value. So the vertex will be the lowest point. If a is less than 0, then the parabola faces down and has a maximum value. Let's jump straight into an example. Find the axis of symmetry, vertex, y-intercept, and the maximum or minimum value of the quadratic function f of x equals 2x squared minus 12x minus 1. So first, we find the vertex by calculating negative b over 2a. Okay? So b is negative 12, a is 2. You calculate this and you get x equals 2, 3. So the axis of symmetry is x equals 3. To find the vertex, you have to put 3 into the function so that you can figure out the y coordinate. So 3 comma, so then you plug in 3. So 2 times 3 squared minus 12 times 3 minus 1 is equal to 18 minus 36 minus 1. And when you calculate that, and then when you calculate that, you will get negative, this is trying to figure out this. It'll be negative 19. So you put this negative 19 over there and you get your vertex, 3 comma negative 19. Now over here, the y, so I'm going to erase this so that I can continue. So that was just some work that we wrote. All right, to get the y-intercept, you have to just look for the c value, which is right over here. Okay, here's the c value. All right, now the a is 2, which means that it is positive. So the parabola faces up. Parabola faces up. So it looks like this. And this vertex is at 3 comma negative 19. So it has a minimum value because it's a lowest point, and the minimum value is negative 19. It is the y coordinate. Okay, make sure that you know that the minimum value refers to the y value of the lowest point. Next, we're going to look at the next form that you should know about, and that's vertex form. F of x equals a times quantity x minus h squared plus k. Now in this form, the vertex is at h comma k, and the axis of symmetry is x equals h. Notice that there's a minus sign here, so be careful about that, okay? Let's look at this example. Find the axis of symmetry and vertex of the quadratic function this, okay? So, let's take a look. Well, if we want to make it match exactly like the form, then I'm going to rewrite x plus 3 as x minus negative 3. And in this case, I can see that this is the h value, negative 3 is the h value, and 5 is the k value. So the vertex is at negative 3 comma 5, and the axis of symmetry is x equals negative 3. Okay? So that's vertex form. It's pretty simple. The next form that we should be comfortable with is the intercept form. And that form is in f of x equals a times x minus m times x minus n. In this form, m and n are the x-intercepts. Vertex is located in the middle of m and n. So let's go to this example. Find the x-intercepts, axis of symmetry, and vertex of the quadratic function f of x equals 4 times x plus 1 times x minus 7. So this is in intercept form. So right away, we can see that the x-intercepts are negative 1 and 7. Now to find the middle of negative 1 and 7, you just average them. So you add them and divide by 2. So negative 1 plus 7 is 6. 6 divided by 2 is 3. So the vertex is 3. 3 comma what? Well, we're going to plug it in. So f of 3 equals 4 times 3 plus 1 times 3 minus 7. So that's 4 times 4 times negative 4, which is negative 64. So negative 64 is the y coordinate of my vertex. And the axis of symmetry is going to be x equals 3. All right, next we're going to learn how to convert from general to vertex form. There are two methods in rewriting this general form to vertex form. Now, why would we want to rewrite that from general form to vertex form? It's so that we can get the vertex, okay? Or to just have it in a different form for different purposes. Okay, now the first method is kind of the longer method, but it's good to review this completing the square process. First, I'm going to factor out a 3, but I'm only going to factor out a 3 from the first two terms. Okay? Now, then we have a little something called completing the square. We want to add something over here so that I can complete the square and get a perfect square trinomial. So you might remember that we take half of 6, which is 3, and then square that number and get 9. So you add 9 over here. Now if you add 9 there, then you also have to subtract 9 over here. But it's 9 affected by a factor of 3. So you have to subtract 9 times 3. You introduced a 27, so you have to subtract a 27 to keep it balanced. Okay? All right, now, this perfect square trinomial, x squared minus 6x plus 9, can be rewritten or can be factored into x minus 3 squared. In fact, that's why we completed the square, so that we can have this x minus 3 squared. All right, then 2 minus 27 is minus 25. And there it is. Okay, so that's method number 1 in rewriting it in vertex form. Method number 2 is to actually find the vertex. And you might remember that finding the vertex, there's a negative b over 2a formula we can use to do that. So this is negative 18 over 2 times 3, and we get positive 18 divided by 6, which is 3. So the vertex is at 3 comma f of 3. So you plug 3 into my function, and you have 3 times 3 squared minus 18 times 3 plus 2, and this simplifies to negative 25. So the vertex is at 3 comma negative 25. So then you take that fact and you insert it into my formula. Now, h comma k is my vertex, and so I have 3 times x minus 3 squared minus 25. So these are two different ways of converting from general to vertex form. One final note, the a value, the lowercase a value in the general form is going to be the same as the lowercase value in the vertex form. Next, try this next example on your own. Pause the video, and when you are ready, you can check your answer by unpausing the video. Go ahead and pause the video right now. Alright, folks, the answer to this is f of x equals to 2 parentheses x plus 4 squared minus 37. Hopefully you guys got that. Alright everybody, now we're going to do 2 examples here on this next slide, on this next page. Now for these 2 examples, you can pause the video if you want, try it on your own first, and then unpause the video to see if you got them correct. You can do that, or you can just follow along as I do example 1 step by step. So let's begin. So first, to find the vertex, and on the side, I'm going to calculate, do some of my scratch work. So first, I need negative b over 2a, because we know that that's how we find the vertex. So the b value here is 6, and the a value here is negative 1. So you have negative 6 over negative 2, which is positive 3. So the vertex is at 3 comma something. And to figure out what the y-coordinate is, I need to insert 3 in for x. I need to calculate f of 3. So I'm going to calculate f of 3 over here on the side, and I get 1. So the vertex is at 3 comma 1. Right away, the axis of symmetry is x equals 3. The y-intercept, you might recall, is just the is just the c value. Or you make x equal to 0, and you're left with just negative 8. So we have negative 8. Now, to get the x-intercepts, you have to set y equal to 0. So I'm going to set this equation equal to 0 and solve for x. I'm going to multiply both sides by negative 1 so that it's easier to factor, if it's even factorable. So then this is factorable, x minus 4, x minus 2, and so my x-intercepts are 4 and 2. Now, if this were not factorable, then I'll have to use another technique, such as the quadratic formula or completing the square. Alright, in this problem, a is equal to negative 1, which is less than 0. So this parabola faces down. And so we have a high point. So we're going to get a maximum value, and the maximum value is the y-coordinate of the vertex. So the max value is 1. Now, the domain is negative infinity to infinity because there is no restriction on what x can be. X can be positive numbers, negative numbers, as big, as small as we want. The range is going to be the maximum value and below. So it's negative infinity to 1, including 1. Alright, for example 2, I want you to definitely pause the video and then unpause it, and then you'll see all the answers written down. Okay? So go ahead and pause the video right now. All right, what you see there is are the answers. Hopefully you got them correct. In this problem, to get the x-intercepts, you needed to use quadratic formula or completing the square, because this f of x was not factorable. All right, to end this lesson, we are going to do 2 word problems that involves quadratic functions. Example 3. Find 2 numbers whose product is a maximum if the sum of the first and thrice the second is 24. What does thrice mean? Thrice means 3 times, okay? All right, so we've got 2 mystery numbers. So let x and y be the 2 numbers. These 2 mystery numbers, okay? Now we learn that the sum of the first number plus 3 times the second number is 24. Now the product is going to be x times y. And so the product is going to be x times y, and we want to rewrite y in terms of x. So here we're going to solve for y. So 3y equals 24 minus x. And so what we have is y is equal to 24 minus x all over 3. All right, so I'm going to call the product p, and I'm going to distribute the x in and also divide it by 3 at the same time. So we have 8x minus 1/3 x squared. Hey, that right there is an upside down parabola with a maximum value. Well, this parabola represents the product, because here we have product equals to this parabola. So the output of this parabola is going to be the products, and the highest output is going to be the maximum product. So all we have to do now is figure out where this vertex is, and that will give us the maximum product. So we know that the maximum product is at negative b over 2a. In this problem, the b value is 8, and the a value is negative 1/3. You have to be really careful. The a value is negative 1/3. So then here we have 2 negatives, and so that becomes positive 12. Now, if x is positive 12, so here we have x is equal to positive 12, then we can use the formula that we have up here to solve for y. So put in positive 12 in for x. 24 minus 12 is 12. Divided by 3, and 12 divided by 3 is 4. So y is 4. So the 2 numbers are 12 and 4. These 2 numbers multiply to be the greatest product it can be, while fulfilling the requirement that the sum of the first and thrice the second is 24. So 12 plus 3 times 4 is indeed 24. Next, we are going to look at this word problem. A rectangular field along a river is fenced in on 3 sides. You have 600 feet of fencing. What is the largest possible area? So these black segments are the fence. One side of it is x, so the other side of it is also x. Now, if I used up x here and x here, how much fencing is left? Well, it's going to be 600 minus 2x, because we have a total of 600 feet of fencing, and we used up 1x here and 1x there. So this last side is going to have 600 minus 2x feet of fencing left. Now we're ready to do this problem. We want the largest area possible. Well, area is length times width. Well, the length is x, and the width is 600 minus 2x. If I multiply this out, I get 600x minus 2x squared. Hey, that's a parabola, and it's another parabola that faces down. The output of this parabola gives you area, because area equals to this formula. So the outputs are the areas, and since it's an upside down parabola, we're going to get a maximum value, which is perfect because this question asks for the largest area possible. So let's figure out where that vertex is. Once again, we use negative b over 2a. So you have negative, and b is 600, and a is negative 2. So you have 600 divided by 4. Okay, so what is 600 divided by 4? Oh, the two negatives, by the way, cancel out. So 600 divided by 4 is 150, which means the two sides have to be 150 each. Now we can plug in our 150 back into our area formula. So area equals 150 times 600 minus 2 times 150. And we can use the calculator here. It's 45,000 square feet, which means that this vertex is located at 150, 45,000. Keep in mind that this 45,000 represents the largest area, because earlier we said that this parabola gives us the area. So the output of the parabola gives us the areas, and the highest output will give us the largest area. So the largest area, to answer this question, is 45,000 square feet. That's all, folks.